Hi everyone, welcome to Midas Geotech webinar today. This is Choi, and Geotechnical Engineer from Midas IT HQ in South Korea. Today I'm talking about Eurocode briefly, and I will show you how to apply partial factor using GTS NX to excavation analysis. After my presentation, I will get a Q&A session around 5 minutes. Let me start my presentation first. Okay, let me explain briefly about Eurocode. Eurocode is a European standard for buildings, bridges, infrastructures, and other design in civil engineering. As you, as you can see on the screen, there are demonstrations about design with the Eurocode for each part from civil engineering industry. We are normally using Eurocode7 to our project for the geotechnical engineers. And there are two parts from Eurocode7, as you may know. The part 1 is for general of geotechnical design, and part 2 is for ground investigation and testing. So I'm focusing on part 1 from Eurocode7 today's session. Let me talk about more geotechnical design with part 1 from Eurocode7. There are 3 design approaches and combinations from each design approaches for geotechnical calculation and analysis. And under the combinations, A is action, which means partial factor for applied load, and M is a partial factor for soil materials, and R is partial factor for resistance. Right. Let me talk about analysis with the FEM program. From my experience, we are using the action A and soil material M to analysis for excavation project probably. And let's move to next slide. Okay, so this is a table for your information, and there are partial factor values from DA1C1 is the design approach 1 combination 1, and DA1C2 is a design approach 1 combination 2. From my experience, I normally used DA1C1 and DA1C2 in my excavation project. So I will talk about DA1C1 and DA1C2 in this session. And actions, as you can see there, for applied load is divided 2 types, such as permanent and variable, and they will be divided 2 again, such as unfavorable and favorable. And from the partial factor values for soil material, it will be affecting to strength of soil, such as cohesion and friction angle. And the values of partial factor from actions will be multiplied to original load, and the soil strength will be decreased when you apply the partial factor compared with the original materials. So I guess you will get a more conservative result compared with the original result, right? So let me talk about how to apply the Eurocode. So for the construction sequence, considering the partial factor in the excavation analysis. For example, your original analysis stage is, as you can see here, initial stage, surcharge, cast the retaining wall and sequential stages with excavate down and install reinforcement. And for this construction stage, you need to do the engineering judgment in this case to apply the partial factor in your analysis stage. From my experience, there are two concepts. From concept number one, perfectly consider the design approaches to analysis stage from start to the end. In this concept, you need to create three analysis files for each approaches, such as normal and DA1C1 and DA1C2. In the concept number two, DA1C1 case is assumed by SLS instead of the normal case and extract the substage from the critical stages. And from this concept, you just need to create one analysis file and using the substage function from your FEM program. I normally did concept 2 when I applied partial factor to my excavation project, but I can't say which concept is correct. Okay, so let's move to how to verify the Eurocode using your FEM program. So you can verify the partial factor function from the FEM analysis program, whether it is working correctly or not. In this verification, you need to create two models which are automatically considering the partial factor using the function from analysis program and keying the factored values from your calculation manually. So from the both analysis, they should be got same result from everything. So if your FEM analysis program is providing the function of partial factor, you can skip your time to calculate the strength of soil and load with a partial factor. And let me close my presentation and open the GTS NX program to see the usage of this partial factor function from the GTS NX. Alright, so this is a GTS NX program and I open the file what I created before. So let me check the material first under the material function here. So under this what material window, you can find the phone number of soils and concrete and steel, and I assume the soil materials using the molecular model type. And as you can see here, you can choose constitutive models which are provided by the GTS NX. And normally we are using the molecular model and soft soil creep, soft soil, and hardening soil, and others. Okay, so under this molecular model, you can define the elastic modulus and the others for the implementation of the elastic modulus and Poisson's ratio, unit weight, and K naught. And under the porous tab, you can define the unit weight with the saturated and the initial void ratio. And also you can define the drain or undrained case. Okay. And also you can give the permeability for 3 dimensions or 2 dimensions. And under the non-linear tab, You can define the equation C and increment of the equations with the height and numbers, and friction angle, and the latency angle, and tension cutoff. Okay, let me open the concrete material, and I assume this concrete material by the elastic model type. And if you wanna consider this elastic model type to structure, you need to check on this one, the structure, and you can define the elastic modulus and Poisson's ratio, unit weight, steel material as well, elastic, and check on the structure. I gave the elastic modulus and Poisson's ratio and unit weight. Okay. And after you define the material, you need to define the properties. Click this one. And the soil materials assumed by the plane strain type for the 2D, as you can see here. And retaining wall is assumed by the beam. Need to check the bending moment and shear force and axial force as well. And strut are assumed by truss. With this truss element, you can check the axial force. And also I gave the sections. You can directly select the member size under here, and you can give the spacing. Okay. Alright, so firstly, I will import the DWG file to GTS NX using the import function. And I will select what I created, open it. Okay, so there are 4 layers of soil condition, and this line is a retaining wall, and there are lines for strut and excavation, right? So the next, I will create the face to select the boundaries line, and OK. And next, I will use the imprint function to imprint those lines on the face. So select target object. Okay, you need to go to Curve tab and select the target object to select the face. And Tools, select the lines, Ctrl A. Okay. So under here, you can directly check the geometry what you created. Okay, so let me hide the curves and surface. As you can see here, the lines are imprinted to the face, so I don't need these curves anymore. So I will delete. Okay. Alright, so just now I finished to create the geometry, and the next I will generate the mesh, and before that I will control the mesh size using the size control function here. Okay, so I will make the fine mesh around the excavation area, and I will make the coarse mesh for the rest part at the boundary until the boundary condition. Okay, so let me select the edges for the retaining wall like this, and I will give the mesh size. And let me check whether it is reasonable or not. Okay. And next, I will give the mesh size for the edges, the okay, the limiter. Wait. Okay, I will choose 8 meter. Okay, so this size control is the engineering judgment. So you need to find the reasonable size for the mesh. I will give the 8, something like this. And I will give some linear grading mesh for here, here, and here as well. Okay, so this one is a starting point, and this is a end point, and you can give the start and end length. Length means the size of the mesh set, so I will give the 1 for start length, and I will give the 3 for the end length. Let me check with the preview mode. Okay, apply, and I will give here is 1 meter for the mesh set, and this one also give the 1, 2, 3 like this. Apply, and here I will give mesh size starting with a 3 to 8, and let me check. Okay, apply, give the mesh size under the rest part 3. Okay, so just now I finished it to control the mesh size for my mesh, and you don't need to follow my mesh size, and I, I think you just remember that you need to give the fine mesh around the excavation site where you need to check, and the rest part you can give the coarse mesh. Okay, so let me generate the mesh and check the mesh condition, whether it is reasonable or not, and I will give the size of mesh is 1, and I will check register each mesh independently. Okay, okay, all right. So I think it is reasonable to me because the around the excavation area is a fine mesh, and the rest part is coarse mesh. Okay, so let me say something about the mesh. You can generate the mesh with a scale like this, a scale and triangle mixed, or Control Z is the undo function, and you can generate the mesh with a triangle only, like this, and quadrilateral only. And I prefer to use a triangle, but the quadrilateral mesh is more accuracy from the some thesis. Okay, and let me check. Okay, right. So let me proceed to generate the mesh for the retaining wall and strut. So retaining wall first. So I will use the extract function here to generate the mesh for the retaining wall. So before that, uh, let me hide the mesh set. You can hide the mesh set. Just check on or check off, and each one by one like this. Okay. So let me show the geometries, and also you can show and hide the control the mesh size point like this. Right, so let me click the extract function here. Okay, so select the edges for the retaining wall here, and I will select the retaining wall property and change the name retaining wall and click OK. Okay, and also you can show and hide like this as I said. Okay, so let me hide the geometry and show only the retaining wall here. Okay, so the next I will generate the mesh for the strut uh, using the create function here, and I will click the starting point and end point for the first strut, apply, and the second strut, the starting point and end point, and select the properties and give the name. Alright, so just now I finished to generate the mesh for the retaining wall and strut. Okay, so the next I will merge the mesh set to verify easily for the excavation meshes. So I will change the selection method to mesh set and select the mesh set here. Okay, so those three mesh sets are excavation part. So I need to merge those mesh set, but before that, we need to give the properties for the mesh sets. Maybe the mesh sets are assumed by the number 4 materials, maybe others as well. Okay, so let me change the display mode to property color. So as you can see here, there is only one third properties. So let me change the third properties, the layer by layer. So I will use this parameters function to change the properties. Go to 2D tab, and then you can see the change property function. Okay, so I will select the first layer, the properties for first layer, and select the mesh set for the first layer and apply. Right, so see the color has changed, and I will select the second layer. Okay. Select the mesh set, apply. Okay, and the third one, change the property, apply. Okay, so just now I changed the properties for each layer. So when you check the property under the properties window, you can see the properties are changed layer by layer like this. And as you can see here, you can verify with a different color. It is better to check. Okay, so let me merge the meshes for the excavation. So I will select the three mesh sets and right click and merge. Then you can directly select as one like this. And I will change the name for this first excavation mesh set. And F2 key is change the mesh set name and give the excavation 1. You can show and hide together like this after you merge it. Okay, this one is the second excavation, so change the name. Okay, and this one is the last excavation, so final excavation level. Right. Okay, so the next I will create the interface element between the retaining wall and ground to make more realistic behavior. So using this one, the interface function, change the type to from truss and beam. Okay, so let me hide the truss, the first and second layer of strut, and select the element, select all. Okay, and merge node at the toe like this. And I will select the widget and give the strength reduction factor is 0.67. Okay, and I will check on this one, the create the rigid link, and okay. Okay, so just now I finished to generate the interface element between the retaining wall and ground. Okay, so the next I will apply the surcharge and go to static and slope analysis tab, and I will use this pressure function and edges. Okay, so let me select the edges for the surcharge, and I will give around 10. Change the name, surcharge, and click OK. Right. So the next I will give the boundary condition like this, and the next I will give the self weight. Okay, so you can see the arrow here. Alright, so this is the main part of today's webinar. Let me create the partial factor for the DA1C1 and DA1C2 using this one, the partial factor function. Click this one. So under this partial factor window, you can see the database for the DA1, C1, C2, and DA2 and DA3. So I will select the DA1, C1 first, and I will give the name and assign. Go to Material tab, and I will select the every materials. And when you have the interface material, or when you consider the interface, that the material will be automatically updated like this, and the interface material also need to select under this material tab. Okay, and load, select the surcharge, and you can give the vector from the phone numbers. Okay, and when you finish to define the materials and load, you need to click add. Then you can see the D1C1 and material. Under the material and load, you can see the circle here. It means it has applied to the material and loads. So next I will create the partial factor for the D1C2 and select the database, this one, and click assign. And you can see the values has assigned for each parameters, and under the material it is still there. Okay, so under this partial factor window, you can see the factored values directly, and then you can check like this. Okay, and load. Okay, so add D1C2, and if you want to modify something, then just double click here, go to material tab, and you can control it yourself and click modify. Okay, so just now I finished to define the design approach 1, combination 1 and 2. Okay, let me close. Okay, so let me show you some one of highlight function of GTS NX. You can open the more than 1, more than 5 at the same window like this, and those files are what I created. Okay, so the next, let me define the water level for the every excavation stage, and you can find the water level function here, and select the edges tab for the 2D analysis. And I will make the initial water level below the 1 meter below the ground surface. Let me check the distance using the F3. From here to here is 1 meter. So let me draw the lines 1 meter below the ground surface on the left hand side. So go to Geometry tab, select the line, and click the starting point. Okay, and give the end point. And let me use a trim function. Cut this line. After the generate mesh and if you draw the lines, it is not affecting to generated mesh. So you just use this line for the water level. So let me click water level function again and click the lines. This one is initial water level, apply. And for the first excavation, you just select the lines like this, apply. And second excavation, apply. And final excavation level. Okay, so you can find the your created water level under this function tree and general function. And when you right click on here and click edit, you can change the values under here, right? So just now I finished to generate the meshes and define the water level and define the partial factors. So next, I will define the analysis stage. And right click on here, the stage set, and I will carry out the stress analysis. And under this stage type, you can choose the stress and seepage and semi-coupled analysis and others. Okay, double click this one. And I will change the stage name. And I will activate every mesh sets without the structures. And you can directly see the activated mesh set when you change this show data to activate. Okay, and I need to activate boundary condition and self-weight. And if you are created the interface element, then you need to activate rigid link at the initial stage to make the separated nodes to assume the one node. And I will check on this one, the clear displacement, and I will give the water level for the initial, save. Okay, so the next stage is surcharge. And I will cast the retaining wall edge wall at the same time, and retaining wall and interface surcharge. So when you activate this interface element, so you don't need to keep the rigid link anymore. So I will deactivate this rigid link and save. And next is first excavation. So I will deactivate this first excavation area here, save, and install the first layer of the strut. Okay, I can't see because of the water level. Save. Okay, under the first excavation, you need to change the water level to for first excavation like this. Okay, okay. Go to second excavation, I need to deactivate the second excavation area and give it the water level. Save. Second layer of strut. And final excavation level. Select the water level like this. Alright, so just now I finished to define the analysis stage. So after that, I need to create the analysis case using the construction stage. So the solution type I need to change to construction stage, and select the construction stage what I created under here. Okay, so if you make more than one construction stage set under here, you can choose from here to give the name to the excavation. Okay, so under this analysis control, you can give the KNA condition for your initial stage, or if you check this one as a gravity condition. Okay, so in this case, the ground surface is a flat condition, so I can apply the KNA condition. So I will check on this one. So under the nonlinear tab, you can find the partial factor function here, the partial factor tab, and check on this one, consider the partial factor. Then you can select the partial factor what you created. So I will select the A1C1 for the every stage set in this analysis case. Okay. So under this analysis case, the construction stages will be applied by the TA1C1, the partial factor, and I will extract the substage from the excavation stage to consider the partial factor, the TA1C2. So give the name and select the partial factor TA1C2 for every excavation stage on the every excavation stage only. So let's take TA1C2. Okay, save. And the final excavation level as well. Okay, so just now I finished to define the partial factor for the analysis stage. For every stages, I did apply the DA1C1, and I did extract the substage from the excavation stage only, and using the and applying the DA1C2. Alright, let me skip the analysis process to save our time, and let me open the result file at the same way what I introduced before. Just drag and drop like this. Right, so let me change something. Okay, so when you finish to carry out the analysis, you can see the trees under the result tab, and as you can see here, there are stages what I created, and also you can see the DA1C2 results as well. So let me open the trees at the last stage and check the total displacement. Okay, so you can directly control the unit system under here. Then you can directly see the values with the millimeter. This is the horizontal displacement, and this is the settlement. Okay, and if we want to see the forces from the retaining wall, it's under the beam element force. And you can directly see the bending moment. Let me change the unit system. And this is shear force. And if we want to see the actual force from the strut, you need to open the truss element forces here and double click this one, the actual force. Okay, and if you move to the other stages, you just click this stages bar like this, and to check the total displacement from the other stages like this. Alright, so just now I finished to use the GTS NX program to show how to use a partial factor function with the GTS NX. Right, so today I did present about Eurocode briefly, how to use function of partial factor in MyDAS GTS NX. In my opinion, there are a lot of engineering judgment in the geotechnical industry, so the sharing the information and knowledge are very helpful to geotechnical engineer. So I will continuously sharing my knowledge next year as well, and I'd like to make you guys more familiar to use GTS NX. And Midas IT has own developer to develop the Midas program, so please give us your feedback to improve Midas program. And if you have any query about webinar session today, please talk to me using the chatting room, and I will take it around 5 minutes, and I will reply on your queries through your registered email. And if you have any further queries, please join the Skype chatting room and talk to me in there. Thanks for watching and listening my webinar session today.